Hi, this is a problem about spreading of a new virus. This is an exponential function, and we assume that the number of computers newly infected by another virus is given by the function v of t is equal to 300 times 2 raised to the t over 2, where t is the number of hours after infection. When we initially ask how many computers were infected initially at t equals 0, this is asking you to recognize that the number 300 here, kind of highlighted, is the initial value. So this is saying that v of 0 is equal to 300. With the doubling time of the virus, which is the next question, we are asking you to recognize that this part of the equation with the t over 2 is part of the equation for a doubling time formula where the t divided by n represents the doubling time n. So the doubling time is 2. And if we're looking at the units there, that has to be 2 hours. So all of this is coming straight out of the formula. The formula tells you that you started with 300 infected computers, and that every 2 hours this number is doubling. So that's going fairly fast. Then they ask, how long will it take for 800 new computers to be infected? That would be something that you can either do symbolically, but you can also do this with a graphing tool. And moving to Desmos, I set up the two equations. So in the red, we have the number of infected virus computers, the 300 times 2 raised to the x over 2. And I want to know, when is this function, so this red one, when is it hitting the level where the number of infected computers hits 800. So I also graphed the line y equals 800, and where they intersect, exactly this point, is where you end up with the red curve hitting an output of 800. And so if you're looking at the coefficients of that point, it tells you that this happens when your x-coordinate, in this case the time, is 2.83. And remember, the units were given in hours, so this means that you are getting to a level of 800 infected computers after 2.83 hours.